Okay, hello there. Welcome back. What I would like to look at today is the Electrical Principles Unit 5 Circuit Theorems. Okay? Now, most of this I've done it in a way where you can read the information for yourselves. And please remember, you must write out the information to make it your own so your brain will record what it has written. Okay? Now let me just move a little bit here, okay? It's just the calculations of the currents in and the voltages across the various parts of an electrical circuit. Okay? Now, I don't want to be reading this out to you. You can read this out for yourselves, okay? But what I want to do is to make sure that you write out the information, you draw all the diagrams, and you make the information and knowledge your own. Now what I've done here is I'm going to look first at the Superposition Theorem. Okay? And this again you can read for yourselves. And what I've done here is to let us look at the circuit drawn in 6a. Now what I've done is draw out the circuit diagram so you can see for yourself what I'm trying to establish or to illustrate. Okay? And again for yourselves, draw out the diagram. Okay? Now I'll start off with the simple illustration of a resistor purely connected at points A and B. Okay? Now assume that a single cell is added at point A, okay, having an EMF of 2 volts and connected with the polarity shown in 6b. Okay. Now again, I'm going to leave you with this. I've shown you the calculations I've carried out here. Now they are simply enough for you to understand and to follow through. Okay. Don't need much explanation on this. Now an application of Ohm's law quickly produces a current shown of 0.2 amps, which by convention will flow in the direction of the arrows. Okay? In short terms, positive to negative. That's conventional flow. Electron actually flows from negative to positive. Okay? That would be electron flow. But as we're dealing, we'll retain it as conventional flow, positive to negative. And again, write this out for yourselves. Read the information, make it your own. Draw the diagrams. Now these you can read for yourselves. I will not need to read this through to you at all, okay? And you can see what we're trying to do here and say. And I've taken it a step further by going through the process of showing you the actual current, how the solutions are arrived at. Write out those solutions, make sure you understand the principle behind them and how they've got that far, okay? Now here I've simply gone to look at the basic principle of the superposition theorem. Okay, read what it says. Do a little research for yourselves so you provide additional information and knowledge to what you have been presented with here. And here I've gone on to an example. Write out the example in full. Do not leave it as undone or any part of the information missing out. You will not read it from screen because it's not yours to read from the screen. You have not written it out, so therefore it will not make anything to you. Write it out, draw the diagrams. Now I've given you the diagram. Now the reason for giving you the diagram in color is that we can see what's happening and it's brighter. Okay. Now my camera here is flashing a little bit faster than I expect, so bear with me if I stop abruptly. My apologies. Okay. I did charge the battery before I started, but sometimes it doesn't always do as you would expect it to do. Now look at the calculations I've done. Make sure you understand them. See that you agree with the calculations values. Now bear in mind that there is a little bit of rounding up, so your calculators might be a bit more accurate in some cases. Again, be aware of that. Make sure the values you arrive at or you see on the screen tell us what you have calculated. Okay? Do not take it as read or as for granted. Okay. Now I'm just moving up this because it's up to you to read this, slow it down, stop it if you need to, put in a break. Okay? And you'll see that it provides you with a great deal of information and knowledge. Look at the diagrams, follow them out, draw them out, make them your own. Okay? We're coming to close here now, okay? Again, and we're coming somewhere here. Okay, now again, I've taken the example from one to another in the sense that it repeats itself slightly in the second part because the process you apply in the first part is what you'll need to apply in regards to the second part. Okay? Now all I've done here is give you a list of equipment that you can use to do a little experiment on a breadboard for yourselves. Okay? And you'll see that it actually works. Okay? It really does work. I know, I've tried it myself. Okay? But remember, you may need more than one multimeter. Okay, but you guys are young and healthy and have lots of money, so you should be able to buy yourself a couple of meters. Okay, right. Now again, thank you for your time, and I hope you find this information useful. Thank you. Again, have a good day, and let's just bring this to an end and a close.